Okay, this is the stoichiometry video number 3. We're going to be talking today about the molar ratio. So, let's see here. Molar ratio. This is a ratio of the coefficients of a molecule or compound in a chemical reaction. So if we have a generic equation of 3a plus b yields 6c. So this is just a general equation. A, B, and C are different elements, different variables, and we have these coefficients here. So my ratio of A to C is 3 to 6, or 3 moles to 6 moles. Honestly, you really can't see that, can you? Yeah. So, try that again. Right here we have each coefficient indicates the number of moles. So my ratio of A to B is 3 to 1, or 3 moles of A to 1 mole of B. And my ratio of A to C is 3 to 6, 3 moles A to 6 moles of C. The ratio of B to C, 1 to 6. 1 mole of B is equal to 6 moles of C. Now, we can also write these a different way. So 3 moles of A over 1 mole of B is the same as saying 1 mole of B to 3 moles of A, because due to our properties of fractions, those are equal, which allow us to utilize these in the stoichiometric equation. So when do we want to use molar ratios? If we want to convert between two different substances. Sometimes we call them species. But if I want to compare how much of A and B and C are going to be in some sort of equation, this is what I use. I use the ratio of the coefficients. So one more hint I want to talk about is keywords. When reading these word problems, they can be confusing. The keyword that you have to use the molar ratio are produced and needed. If you see these words on a word problem, that means you have to use the molar ratio. You have to use the molar ratio every time. So for example, I would say, given 16 grams of A, calculate how many moles of C are produced. Or given 16 grams of C produced, how many moles of A are needed? That's the terminology that we use, and this is how we know we have to use the molar ratio. So let's do an example. We'll go back to our generic equation for right now. We have given 128 grams of A, find, grams of C produced. Now this is my key. If I see the words produced, That means I'm comparing the two things. And in this case, I'm going to be comparing A and C. Remember, these are just variables, not carbon. Which my molar ratio is, from the given equation, 3 moles of A is equal to 6 moles of C. All right, so what do we do? Let's start with what's given. 120 grams of A. Now, what unit goes in the lower right-hand corner? Same one that goes up here. So grams of A. Well, I want to first convert to moles. Which brings me to the question, how many grams are in 1 mole of A? Well, if I look up the molar ratio, let's say it's 24 grams of A is equal to 1 mole of A. Now I can convert to moles. Now the same unit that goes down here, I can use my molar ratio. Moles of A, moles of C. My ratio is 3 moles of A to 6 moles of C. Alright? I'm going to, same unit, so down here's moles of C. In 1 mole of C, I'm looking for grams of C. 13 grams of C. Solve this. I can first cancel out my units. Grams of A, moles of A, moles of A, moles of C, grams of C. Exactly what I'm looking for. It's 128 times 6 times 13 divided by 24 times 3 gives me about 138.6 grams of C, like 7 grams of C. So that's an example of how we want to use molar ratio. So another review, take a step back. First we have what's given. That's in our first parentheses. Second parentheses, we have the molar mass. Mass of whatever is given. Whatever element that's given, that's the molar mass that goes first. Next, we have the molar ratio. We have the molar mass, what we're trying to find. And that's it. So, if there's something to memorize, it's this. You want to know what molar mass, we'll start with what's given, times the molar mass that's given, times the molar ratio, which allows us to convert between substances, and then times by the molar mass again. That will give us mass that is produced or needed. Now, what's funky about this is I don't have to go to molar mass. I can also just end at moles. After the molar ratio, I'm converting between 1 mole and 2 moles. So, given another example of a question, given 16 moles of B, find the moles of A needed. Well, start with what's given. 16 moles of B times my molar ratio. My molar ratio is going to be 1 mole of B to 3 moles of A. Now, if I cancel out my units, I'm left with just moles of A, and that's what I'm looking for. So I'm done. And I can just calculate 16 times 3. 3 times 6 is 8. 8 times 3, 4, 48. Moles of A needed. Can't draw. So, we can just use the molar ratio here to indicate if we're looking for just the number of moles. So there are two different types of examples I'm going to ask you. We'll talk about more in class. Otherwise, take the quiz and I'll see you in class.